Hey guys, we're continuing in lesson 2.1. If you want to pause the video and go to your textbook and pull up the resource, we are going to do the math. Alright, so we're going to look at a couple examples both here and I have a couple more on my screen, and we're going to go through a couple examples, try to make sure that you are ready to go. Alright, so it says use any method to solve the equation 18x squared plus 5 equals 19. Alright, let's see if I can pull this up so I can write on my screen. Alright, so if we have 18x squared plus 5 equals 19, in order to solve that, I'm going to subtract 5 from both sides. Bring down my 18x squared. And then 19 minus 5 is 14. We're solving for x, so we're going to divide both sides by 18. X squared equals, since both of these are even, I know they're both divisible by 2. So 14 divided by 2 is 7, and 18 divided by 2 is 9. So all I did was reduce those by a common factor. All right, now I'm going to take the square root because I'm solving for x. So the square root cancels something squared. Again, I'm solving an equation, so I'll have to do the same thing on both sides. Okay, don't forget that is a 7 here. Alright, so I've got x equals. Now, when I take the square root of an unknown, that could be a positive or a negative, because if you remember, 2 squared is 4, and then negative 2 squared is also 4. So when we're taking the square root of an unknown, we don't know if that's a positive or a negative. So you can put the plus minus symbol here. And then this is the same as square root of 7 over square root of 9. And x equals plus or minus. The square root of 7 is irrational, so it's going to stay. The square root of 9, 9 is a perfect square. So 3 squared equals 9, so the square root of 9 is 3. All right, so that's how we get our answer. Over here in the box, it just says x equals plus or minus. So we're going to need to put x equals plus or minus the square root of 7 over 3. So let's look here. We do have a fraction symbol here, so we're going to put in square root of 7 on top. And then we're going to arrow down and enter a 3. All right, we can scroll down and check it to make sure that we are correct, and then move on to number 2. All right, it says use this information to answer part A and B. The final velocity of a car that is accelerating from rest can be found with the expression v squared equals 2ad. Where v represents the final velocity of the car, a represents the acceleration of the car, and d represents the distance of the car. If a car travels at a rate of 3 miles per second squared and it travels 100 meters, find the final velocity of the car. All right, so we know a is acceleration. We know v is velocity, and we know d is distance. We also know that it travels at a rate of 3 meters per second squared, and it travels 100 meters. All right, so if we come down and look at what we are given, it says we've got v squared equals 2ad. That was the equation they gave us above. All right, and they filled in the 3 meters per second squared, and they filled in the 100 meters. So the A, acceleration, that's your rate, and the distance was 100 meters. So what do you get for the next thing? So the parentheses here tell you that they are multiplying. And if you multiply 2 times 3, you get 6, and 6 times 100 is 600. So we're going to have 600 meters squared divided by speed squared, or s squared. All right, so now we have v squared. We're trying to get v by itself, So we're trying to solve for v. All right, so we're going to take the square root of both sides. If we take the square root of both sides, that means all of this will be under the square root. So we're just going to bring that 600 down. And then we have to break up the square root. All right, so back in either Algebra 1 or Integrated Math 2, whichever class you were in, you would see how to break down a square root. So the square root of 600 can be rewritten as 100 times 6. And if you wonder why 100 times 6 is just 600 broken down, but if you wonder why I chose these two numbers, because 100 is a perfect square, 10 squared. 10 times 10 is 100. So I can bring that out, and the square root of 6 is left inside. So down here, when you're trying to fill in these blanks, that's what you're trying to do. You're trying to rewrite this as 10 square roots of 6. And then if you want to know what the approximate, this means approximate, that basically means they've just typed this number right here in their calculator. So if you type this in, and it's probably going to tell you up here, don't forget, it says show your work, round your final value to the nearest tenths. So tenth means 1 decimal place. So if you type this in your calculator, you're going to get 24.5 when you round it. When you check that, you can see that that is correct. All right, the next part says, explain why there are two answers to this question. Find the words from the drop-down list to correctly complete the explanation. There are two answers to this question because the positive and negative signs indicate the direction, and the car could be going in a positive or negative direction. So if you think about whoops, I didn't want to submit that. Let's go back. All I wanted to do was check it. If you think about a graph on a number line, your x's go left or right. So when you're talking about driving a car, going in the positive and negative direction just means that you're going positive in the x direction or negative in the x direction. All right, I want to look at a couple more examples just to give you guys little information on this unit. So 2.1, use square roots to solve quadratic equations, and it has an imaginary unit in this section. So you learned this a little bit in Math 2. I don't know if you learned it in Algebra 1. If you came from Algebra 1, this may be new to you. So some of you guys have seen this before, some of you may not, but I'm going to show you now. Either it's a review or it's brand new. You need to know the imaginary unit I equals the square root of -1. Okay, so this allows us to solve equations with imaginary solutions. So if I have x squared equals -4, I'm going to take the square root of both sides, and I'm going to have x equals plus or minus, and the square root of -4 is the square root of 4 times the square root of -1. All right, so we already know that the square root of 4 is 2, but the square root of -1, we now know that is I. So it's going to be 2i. So plus or minus 2i. So if you have x squared equals the square root of 4, x squared equals 4, and you do x squared equals 4, and you take the square root of both sides, you're going to get x equals plus or minus 2. All right, so if it's positive, you're just going to get the same thing you have done before. Now, if you have a -4, you're going to have an I as part of your answer. So let's look at a couple more examples real quick. All right, so we've got x plus 2 quantity squared equals 2. So the first thing we need to do, since this is in parentheses, we have to get rid of the squared term first. So we're going to take the square root of both sides. So the square root cancels the squared, and that leaves me x plus 2 equals plus or minus the square root of 2. All right, then we need to subtract 2 from both sides. X equals negative 2 plus or minus the square root of 2. Now, if the square root of 2, had been a perfect square, then you could break that down. Or even if it has a perfect square in it, you can break that down. But since it doesn't, that is your final answer. So x equals negative 2 plus or minus the square root of 2. You can see this one does not have an imaginary part. All right, let's look at this one. All right, this one has a number outside the parentheses. So now we have to get rid of that number first by dividing. That's multiplication. So the opposite or the inverse operation is division. So we're going to have x plus 5 squared equals 8 divided by negative 2 is negative 4. Now we're going to take the square root of both sides to get rid of that squared term. So we have x plus 5 equals the square root of negative 4. So again, that's the square root of 4 times the square root of negative 1. So that's going to be 2i. Then we subtract 5 from both sides, and we get x equals negative 5 plus or minus 2i. Again, once I take that square root, I'm going to have that plus or minus sign there. All right, so x equals negative 5 plus or minus 2i, which brings us to what a complex number looks like. So a complex number or a complex unit is always in the form a plus bi, where a and b are just numbers. So in this case, negative 5 plus or minus 2i, negative 5 and the 2 are your a and b. So a complex number is written in the form a plus bi. Basically just saying that the imaginary part will be on the end of it. All right, let's try to get in one more example quickly. All right, for this one, we're going to add 8 on both sides. We're going to have 3x squared equals 8. Divide both sides by 3. X squared equals 8 over 3. Take the square root. X squared equals plus or minus square root of 8 over square root of 3. And then we have to rationalize your denominator. So we're going to multiply top and bottom by square root of 3. If you multiply by anything over itself, you're just multiplying by 1. So we're just manipulating this problem to get rid of, I didn't mean to draw that line on there. We're just manipulating this problem to get rid of the square root in the denominator. All right, so we're going to have x equals plus or minus square root of 8 times square root of 3, square root of 24, and anything, a square root times itself is just that number. So the square root of 3 times the square root of 3 is the square root of 9, but the square root of 9 is just 3. So anytime you have a square root times itself, you know it's just going to be that number. Now, 24 is not a perfect square, but it does have a perfect square in it. So 24 has, let's see, 4 times 6. And 4 is a perfect square. So if you think about the square root of 4 by itself, square root of 4 is just 2. Square root of 6 is not a perfect square. And that would be your final answer. All right, if you have any questions, let me know.